Hi, I'm Larry Dignan from Constellation Insights, and we're here with Mark Katz, the CTO of Financial Services at Hitachi Vantara. Hi, thanks for joining us.
Thanks, Larry.
So what use cases do you think are best for enterprises in generative AI?
Generative AI itself is fairly new to the commercial space. Obviously, it's had wide exposure from the ChatGPT intro on the Google and Microsoft websites and the like. But in the commercial space, it's still fairly new. The leading use case that commercial enterprises want to use generative AI for is for virtual assistants and recommendations engines, where on the .com public-facing websites or on the mobile apps, they'll say, use our virtual assistant to answer your most common questions. How do I open a checking account? What retirement vehicles would be best for me? So those sorts of things. Those are the use cases that are top of mind right now that are trying to be engineered for enterprises.
And that's all about productivity and savings, basically.
It's largely around both productivity savings internally, but also giving customers the experience of not having to wait for an agent. Your wait time is 35 minutes. This way they can have an interaction. If 50, 60, 70% of the questions can be screened initially, you're giving a better experience and saving efficiency on the back end.
Does that mean we're going to have small language models for every use case, and how do we stay out of small language sprawl?
In the commercial space is definitely moving more to the small model from the large model. And the idea is that by using small model, we can tune individual AI instances to the use case it's going to be used for. So it has all the knowledge required to interact with the customers or fulfill the use case that it's needed. And by doing small language models and training it on a fixed data set, you avoid the pitfalls of the large language model, which is where you introduce biases and errors into the fact. But it's a really good question about the model sprawl. So there's a number of models already available in the public domain that are trained up to a certain point, and then you take that model and then train it for your specific use case. So the number of models will definitely increase, but there'll have to be a right sizing of that where the base model gets trained up to a certain extent to have a certain capability, and then that same base model can then be trained on separate data sets to fulfill related use cases so that it contains the sprawl. But it's an excellent question. There's going to be more than one, but the idea is to keep it to a manageable number by using a base model trained on different data sets.
And where is this going to get processed? We have on-prem, we have cloud, we have private cloud, we've got edge, we've got smartphones. Where's this stuff getting processed?
The reality is that these AI models run on GPU compute farms. And the GPU compute farms, first of all, they're supply constrained. There's only a few suppliers of them. Very difficult to get them. And second of all, they consume a lot of power. So not everyone has the wherewithal to just run these things. They just don't have the data center capacity or space or power to run it. There are some of the hyperscaler clouds already have significant capabilities to run these things. And so that's a very good place to avoid the GPU problem that we just talked about, where you could run it there. The idea is you could train the model, even train it on-prem, but then once it's used in interactive actual use, it runs out of the cloud. But not every cloud has all those capabilities. It varies tremendously widely between clouds. So if your hyperscaler of choice, if your cloud partner of choice doesn't have that, then you may have to run this on-prem. Or if you can't run it on-prem, you bring up a near cloud experience like a hosting experience. Those co-data centers are equipped for the power and cooling that's required for this, and they can help you host that off of your own premises without having to depend on the native hyperscaler capabilities. So the answer is it's going to run wherever it can. There's tremendous scalability and promise in some hyperscaler clouds. There's not in others. So it's going to be run both on-prem if you have the capability in your hyperscaler, if they have that capability, or in a near cloud co-data center.
So either way, they're going to be moving the data closest to where that needs to go.
Either way, the data that gets consumed by the model has to be adjacent to the model itself. That's absolutely right.
Any regulatory concerns we need to think about?
So there are certainly regulatory concerns here. First of all, folks have already run into issues with training data sets where they've tripped over copyrights. So we talked about training on social media feeds and the like. You have to be very careful not to trip over content that you don't have rights to. So there is certainly content concerns. Then there's also concerns where you don't want to expose yourself to liability. If you give someone a wrong answer and then someone makes a bad decision, there could potentially be customer liability for that. Lastly, although the regulators haven't focused on this space yet, they're adjacent to this space right now. They're just getting finished with the cyber resilience space, and they've become very focused on data. And that focus on data is leading them to this topic. So the things like responsible AI and explainable AI are going to become very important guardrails where you can go back to regulators and they say, well, show me that you don't have biases in your model, or show me that how do you arrive at this answer that you gave someone? Show me the chain of custody of the knowledge that you just transferred. So that regulation is coming. So this year was the year of cyber resilience. The year before that was the year of privacy. Next year, the regulators are totally going to be focused on the AI and large language model, generative AI space.
There's a lot of work ahead.
A lot of work ahead.
All right, thanks for joining us.
Thank you very much, Larry. I appreciate it.